How are you guys? So, welcome back to my channel. And in today's class, we'll discuss about Hungarian method. So, in the all previous class, we have discussed about assignment problem and the details, the uh, types of assignment problem, the reason of assignment problem, and in this video we will learn how to solve any assignment problem. So here only one kind of assignment problems solution method, that is Hungarian method. Now you can see on my board, that is Hungarian method. So this is the most easy and fastest method to understand and solve your problem. So um, uh, during learning the Hungarian method, you have to follow certain methods. So at first we'll comes to know about the methods, the name of the methods. So here you can see it's written Hungarian method. Following steps are to be followed. Number one, step number one, row operation. Step number two, column operation. Step number three, optimality testing or degeneracy testing. Step number four, remove degeneracy. Step number five, zero assignment. Step number six, computation of cost and profit. So guys, ये इधर जो ये जो सिक्स मेथड्स, सिक्स जो स्टेप्स आपको दिख रहा है, सो with this six method you can solve any type of assignment problem. Okay, with this six method you can solve all all kind of all kind of assignment problem. Assignment problem we can solve. Okay, with this six steps. Okay, so now we will discuss about in details with the sixth step what is really meaning with the each step. So now I will describe here. So at first, before describing the steps, I think I would like to give you a proper assignment, that is balanced and a minimization type of assignment problem. So here you can see it's written here. So today we will solve balanced and minimization type of problem. So you know that is balanced mean, what does it mean balanced? You know that balanced mean number of rows equals to number of column. Number of rows equals to number of column. And minimization type of problem means in the question there will be some certain kind of term which related with cost, like selling cost, distribution cost, advertisement expenses, office expenses, factory expenses, time, distance. All of this type of certain words will be mentioned in the question, then you will recognize that as a minimization type of assignment problem. So today we will solve balanced and minimization type of problem. So here it is the step one, row operation. So if I discuss the step one, the row operation, what is column operation in theoretically, then there will be some problem to understand the real meaning of this step. So from that I would like to give you certain a problem and to explain each and every step through solving this problem. Okay, so at first we will read step one. So so our problem number one, the example, first example I have taken, that is minimization type and balance problem. So there is no doubt this question is going to be solved with minimization type of assignment. Okay, so step 1. So in this step 1, we can see it's written here step 1, that is row operation. That is row operation. So what does it mean? So now we can see it's written here, select the minimum element of each row. Row means the इस मैट्रिक्स में जो रो होता है उसी को इंडिकेट कर रहा है ये रो ऑपरेशन. तो हमारे मैट्रिक्स में जो रो होता है उसी को इंडिकेट कर रहा है ये रो ऑपरेशन. So select the minimum element of each row and subtract it from other element of that particular row and prepare a new matrix. So whatever the matrix given in the question, we have to select the minimum element from each row. How many rows are given we don't know, but the certain number of rows are given in the question. We will select the minimum number from each row and we will subtract it from other element. And so after reading this row operation, I would like to come in the question. So we will read step by step and we will solve the step. So that would be the finest method to understand the step. What does it mean? So in problem number 1, we can see it's given that in a textile sales emporium, 4 salesmen A, B, C and D are available to 4 counters W, X, Y, Z. So here are 4 salesmen who are available for 4 counters, that is A, B, C, D. The 4 salesmen available for the counters W, X, Y, Z. Okay, each salesman can handle any counter. Okay, the service in hour of each counter when manned by each salesman is given below. So guys, you can see the service in hour. So hour means time and times is indicating in the question, so we can easily understand that this question is indicating that behavior like assignment, like minimization type of assignment problem. So here it is, here the matrix given in the question, that is counter, sorry, yes, so that is counter W, X, Y, Z and the salesman is A, B, C and D. Okay, so here it is the matrix, and in the and now in the at the bottom of the our problem is given that how should the salesman be allocated appropriate counters so as to minimize the service time minimize. So it's indicating that particularly with this word minimize, so we can easily understand that is a minimization type of problem. And here we can see there are 4 rows A, B, C, um, 4 rows are given here A, B, C, D and 4 column, 4 rows W, X, Y, Z and 4 column A, B, C and D. So it is a balanced problem, and in the question is mentioned that this is a minimization type of problem. So at first we will solve the step number 1. So what kind of questions it is, so at first we have to write it down, then we will solve it. Okay, so let's do that problem. So now here we can write solution. Okay, at first we will describe the problem in the solution. We'll start our assignment problem like this way. The statement, the given assignment, this is assignment, is not a statement. The given assignment, the given assignment problem given assignment problem the given assignment problem is balanced. The given assignment problem is balanced as well as minimization 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 type of problem. Now apply Hungarian method we get. Now apply Hungarian method we get. Hungarian method we get. Okay. So at first in our problem, sorry guys. Yes. So here you can see now we will draw the matrix here. So then we will solve it. At first we will draw the matrix, then we will solve it. So here we can write down like that: counter and salesman, and here it is A, B, C and D, and here the four counters are W, X, Y, Z, X, Y, Z, W, X, Y, Z. And the question it is written that 41, 72, 39 and 52. In the next row, that is 22, 29, 29, 49 and 65. For Y, that is 27, 39, 27, 39, 60 and 51. And the last row is 45, 50, 48 and 52. So this is the matrix given in the question. So from after that, now we will go through our steps. So we can remember the step 1, naming with step 1, then it's naming with row operation. Row operation. Step 1, that is row operation. Okay, so in the row operation, what has said, that is row operation, select the minimum element of each row and subtract it from other element. Select the minimum element of each row and subtract it from other element of that particular row and prepare a new matrix. So at first we have to recognize the, we have to select the minimum element. We have to select the minimum element of each row. So in the first row, which element is minimum? 41, 72, 39 and 52. So 39 is the minimum, 39 is the minimum, and subtract it from other element. Okay, then at first we will select the minimum element, then we will subtract it and create a new matrix. So in the very next row we can see the minimum element is 22, 29, 49, 65. So 22 is the minimum element in the next row, and in the third row we can see the minimum element is 27, 39, 60 and 51. So 27 is the minimum element. 27 is the minimum element, and in the last row we can see 45, 50, 48, 52. So 45 is the minimum element. Okay, so it is our first job to select the minimum element from each row. Now we will create a new matrix subtracting with each other. Okay, so we'll write down like that. We'll write down like that counters here. We'll write down again and again and again the matrix in each of the step. Okay, so salesman, and here you know that is A, B, C and D, and that is W, X, Y, Z. So from that you can see the minimum element. We have to select the minimum element and we have to subtract it from other elements. So minimum element is 39. So we have to subtract it from other element. The minimum element is 39. So the first row is the first row element is 41 and minimum row is 39. So we have to subtract it 39 from 41. The answer will be 2. The answer will be 2. Then the next one is 72 and we have to subtract it from we have to subtract 39 from 72. So we can get 33. So we can get 33, and from 39 to 39, that will be 0. And in the next, that is 52. So we have to subtract 39 from 52. So that will be 52 minus 39, that will be 13. Okay, so from the very next row, that is 22 is the minimum. So from 22 to 22, that will be, that will be 0. And the next one is from 29 we will deduct 22. So 29 minus 22, so that will be 7. And from 49 to minus 22, that will be 27. That will be 27. and from 65 we have to deduct 22, that will be 30, that will be 43, that will be 43, that will be 43. And in the next row, that is 27, so we have to deduct 27 from 27, so it will be 0. And the next element is 39, so we have to deduct 27 from 39, the amount will be 12, the amount will be 12, the amount will be 12. And then it will deducted from 60, so the amount will be 60 minus 27, that is 33, that is 33, 33. Okay, okay, that is 33. And we have to deduct 27 from 51, so 51 minus 27 will be 24, 24. And the last row it's saying that it is 45, so we have to deduct 45 to 45, so that will be resulting 0. And the next is 50, so we will deduct 45 from 50, so we will get answer 50 minus 45, that is 5, 50 minus 45, that is 5. And the next one is 48, so we have to deduct 45 from 48, so 48 minus 45, we will get 3, we will get 3, we will get 3. And from 52 we have to deduct 45, so that will be answer 7, 7. Okay, so here we can see the new matrix have been created. So it is the new matrix in the step 1 has been said to create. So we have created this matrix. Now we will go for our next step. So next step is naming with column operation. So next step is column operation. We can see, so in this next step, this is column operation. So in the column operation it is saying that select the minimum element of each column and subtract it from other element. Select the minimum element of each column. So why it's always mentioned in the question that is select the minimum element, why not maximum element? Because this is a minimization type of problem. If the problem comes with maximization type of problem, then the minimum term will replace by maximum. So in this is a minimization type of problem, so it is the method to this is the method we have to follow. So select the minimization element, minimum element of each column and subtract it from other element of that particular column and prepare a new matrix. So in this step 2, in this step 2 we have to draw, we have to select the minimum element from each row, so that will be deducted from this element, that will be deducted from our step 1, not from the previous step, not from the previous matrix. We have to select, we have to create the new matrix in step 2, it will be derived from our step 1, not from our previous matrix. So our step 2 matrix will be created, which will be derived from our step 1 format, step 1 matrix. So it will be written down like that: step 2, step 2, step 2, that is column operation, that is column operation, column operation, that is column operation. So in this step we have to select the minimum element from each column, and this step will be derived from our step 1. So in the step 1 we can see the in the step 1 matrix we can see the minimum element of each column. So the first column is 2000, 2000. So the minimum element, what will be the minimum element? So we can see the minimum element is 0. So we can select any 0 from this triple zero. So I have select the middle one. You can select any one of them because the result of 0 will be 0. Okay, so at first we will select the 0 from each column, then we will go to create the new matrix in step 2. And the in the next column we can see the minimum element is from 33, 7, 12 and 5. The 5 is the minimum element. The 5 is the minimum element. And in the next column number C, we can see that the here 0, 27, 33, 3, 33 and 3. So here we can see the minimum element is 0. The minimum element is 0. And the column D, we can see the minimum element is 7. Minimum element is 7. So our selection of minimum element is done, and now we will deduct and create a new matrix in step 2. So in this step 2 you can see it's naming with column operation. So now we will draw the matrix. That's naming counter salesman A B C D. Okay, so first one is W, the next one is X, and the very next one is Y, and another, the last one is Z. So now we will calculate the new matrix. So we have to select the minimum element. So what is saying, we will read it again, the rules. Select the minimum element of each row and subtract it from other element of that particular column and prepare a new matrix. So we have to select the minimum element of each row. So the selection of minimum element is already done, and so subtract it from other element of that particular column and prepare a new matrix. So now we have to subtract the minimum element from other element. So in the first column we can see that is 0, and 0 will be subtract from other element. So if 0 is subtract from other element, so you guys know that the all answer will be same. So that is 2, 0, 0 and 0. And in the next column you can see the minimum element is 5. So at first we have to deduct it from uh, row number W, that is 33. So from 33 we will deduct 5. So from 33 we will deduct 5. So that will be resulting 28. Okay, so from in row number X, so we can see here the element is 7. So we have to deduct 5 from the 7. So we will get the answer 2. Okay, so now in the next one is Y, and the answer is getting 12. So we have to deduct 5 from 12. So the answer will be 7. The answer will be 7. So the answer will be 7 in the next column. So now we have to deduct 5 from 5. So the answer will be 0. Okay, so the answer will be 0. In the next row we can see Here again the minimum element is 0, so all the other element will remain same, because if you deduct 0 from any element, so the element will never change, so the element will be same, like in this as like step 1. So 0, 27, 33 and 3. So we'll write it down here: 0, 27, 33 and 3. 33 and 3. And the last column we can see the minimum element is 7, so we have to deduct 7, we have to deduct 7 from 13. So sorry, we have to deduct 7 from 13, so the answer will be 13 minus 7, so the answer will be 6. 13 minus 7, so the answer will be 6. Answer will be 6. And the next one is 43, so from 43 we will deduct 7, so the answer will be 36. Answer will be 36. The answer will be 36. The answer will be 36. From 43 we will deduct 7, so answer will be 36. So and in the next one is 24, so we have to deduct 7 from 24, so the amount will be 17. The amount will be 17. The amount will be 17. Okay, so amount will be 17, and now we have to deduct 7 from 7, so the answer will be 7 minus 7, that will be 0. That will be 0. So here you can see the next step number 2, the column the new matrix has been created. So now there is, I think that there is no confusion. We are going to make this step through our rules given here, so we are just following the rules and solving the step wise each and every method. Okay, so now we will read step 3. So in the step 3 we can see the optimality testing or degeneracy testing. So what does it mean? So at first read it out. Draw the minimum line horizontally or vertical to cover all the zero. To cover all the zero, so we have to draw the line, minimum line to cover all the zero. So we have to draw minimum line to cover all the zero, and if number of lines equals to number of rows, if number of lines equals to number of rows, that implies there is no degeneracy. Okay, so we have to draw line, minimum line to cover all the zero. If number of lines equals to number of rows and column, then that implies there is no degeneracy and allocation is possible. And what is degeneracy? Degeneracy means problem arises. Degeneracy means problem arises. You can see, I think you can see that line. Degeneracy means problem arises. Degeneracy means problem arises. So if problem arises, then we can't allocate the element, so we have to wait and we have to remove degeneracy. But if number of lines equals to number of so at first we have written out that is equal to, so now we will write down like that, this is not equals to. Okay, so this is not equals to, but if number of lines not equals to number of rows and column, that implies degeneracy arises and allocation is not possible. If degeneracy does not arise, then allocation is possible, and if degeneracy does not arises then allocation is not possible. Okay, and if degeneracy arises, so we have to remove degeneracy in step number 4. So at first we will implement the step number 3. Okay, so then we will understand what does it really mean, step 3, to remove degeneracy, and what is the thing, the naming with degeneracy. So now in this step 3 we will write down like that. Step 3, step 1, step 2, and in the step 3, this is the step, this is going to happen. Step 3, that is optimality testing. optimality testing optimality testing optimality testing and degeneracy testing. Optimality testing and degeneracy testing, it is the headline. Okay, so from step 2, at first we have to copy the step 3. I think I can write it down like that. Wait, yes, no guys. Oh, we can't. So I thought I can write down like that. Yes. Okay, I think that should not be fine. So I think we should write it down again. So we have to copy that things, that is column operation. So this is the new matrix we have to copy at first. Then we will continue with our step allocation. So that is counter and that is salesman A, B, C and D. W, X, Y, and the last one is Z. So you'll just copy that. That is 28 22806 22806, and the next one is 0 2 27 36 27 and 36, and then next one is 0 7 33 and 7 0 7 33 and 17 0 7 33 and 17, and the next one is 0030. Okay, 0030. Okay, so now we will read again the step number 3, that is draw the minimum line horizontally or vertically, whatever will be. So we have to draw the line and we have to cover all this 0, and if number of lines equals to number of column, then there is no degeneracy and allocation is possible, and means that there will be no problem, so we can continue with our next step. But if the degeneracy arise, so at first we have to remove degeneracy, and for that purpose we have to go in our next step, that is step 4. Okay, so in step 3 we can see we have to cover all the 0. Okay, we have to cover all the 0 at first. So we have to cover all the 0 with minimum drawing line. So at first we have to cover all the 0 through drawing minimum line. So we can see in the first column there is 30, and in the last row there is also 30. So we have to draw line so to cover all these zeros. So we can draw line. So here you can see we have, I have draw a line to cover all the zero, and we can draw the next line that is cover all the zero. So here we can see another zero is remaining here, so we have to cover that zero like that. So how many lines we have draw? That is one vertical line and two horizontal line. So now we can see we have covered all the zero, and here we can see there is number of rows is 4, number of column is 4, but the number of lines is 3. So number of lines equals to 3 and number of rows and column equals to 4. So here you can see the number of lines not equals to number of rows and column, because number of lines are 3 and number of rows and column are 4. So this is not equal, so degeneracy arises, and so allocation can't be done now. So now we have to write it down like that. We have to write it down like that. We have to write it down like that. Here number of lines, here number of lines equals to 3, which is not equals to number of rows and column. So number of lines equals to 3 and number of rows and column equals to how much? That is 4. So here it is. So you can see we'll read it again, the step number 3, that is draw the minimum line horizontal or vertical to cover all the zero, and if number of lines equals to number of columns, then there is no degeneration, allocation is possible. But degeneration means problem arises, but if number of rows not equals to number of rows and column, number of lines not equals to number of rows and column, that implies degeneracy arises and allocation is not possible. So we have to go through that, and we have to write it down like that. Allocation is not possible. Number of lines equals to 3, so now we will write down. So degeneracy arises. It is my opinion to you guys. If you see the full-fledged video before, and then if you write down through pausing the video, so that will be more productive for you guys. Okay, so at first, so don't write in your copy with simultaneously to see this video. Okay, so degeneracy arises, comma, allocation can't be done, allocation can't be done. So here you can see it is the step 3. So for that, now we will go in step 4. In step 4, it is step 4. In the step 4, we have to remove the degeneracy. So the degeneracy arises in step 3, we have to remove it now. So now we will, at first we will read the step number 4. So in the step number 4, it is saying that remove degeneracy. So select the minimum element on which no line is drawn and subtract it from the other element on which no line is drawn. Repeat it again. Select the minimum element on which no line is drawn. We have to select the minimum element on which no line is drawn. So what is the element where no line is drawn? That is 2, 27, 36, 7, 33 and 17. So here it is the remaining element on which no line has been drawn, and what is saying again, element on which no line is drawn, and add it in the intersect point but other crossed element remain constant. So add we have to select the minimum element. So what will be the minimum element in our step 3 on which no line has been drawn? That is 2. We can see that is 2. 2 is the minimum element on which no line has been drawn, and we have to what is saying that is and subtract it from other elements, and we have to subtract 2 from other element. We have to subtract from other element on which no line is drawn, so we have to subtract 2 from other element on which no line is drawn. So we have to subtract 2 from other element like 27, 36, 7, 33 and 17 on which no line is drawn. So in this element no line has been crossed, so it is our duty now to deduct other non line drawn element from 2. Okay, and in our step 4 we can see again it is saying that drawn and add it in the intersect point, but other crossed element remain constant. So we have to add this minimum element. At first we have to deduct on the element on which no line has been drawn, and we have to select the particular element on which we have to add this 2 in the intersect point. In the intersect means in that point where the vertical line and horizontal line crossed each other. So according to the description of step 4 we can see the intersect point is, the number one intersect point is, that is the intersect point, and that is the intersect point. Is there any no, there is no intersect point more. So we can see here it is, the two intersect points are given in that way. So we have to add it 2 with this intersect. So after adding that will be 4, and we have to add 2 with this intersect point, that will be 0 plus 2, the result will be 2. And what is the thing next? That is point but other crossed element remain constant. So the other crossed element, there will be no change, that will be same as before. Okay, so other element on which the line has been drawn, that is 28, 0, 6, 0, 3, 0, there will be no change. That is 28, 0, 6, 0, 3, 0, there will be no change. That will be whatever now, so that will be same as now. Okay, and again we have to draw some horizontal and vertical line to cover all the 0. After this adding and deducting calculation, we have to draw some horizontal line and vertical line to cover all the 0 again. Okay. So now after adding and deducting the element, we have to cover now all the 0. We have to cover all the 0 with drawing line, and if subsequently there is number of lines equals to number of rows and column, then it shows there is no degenerate. So after adding and deducting the minimum element, we have to draw again the lines on these, and then if we get any kind of if we get number of lines equal to number of rows and column, then there will be no degeneracy, so we will step forward in step 5. Okay, we will move forward in step 5. So now according to explanation of step 4, we will write it down here. We'll do our step 4. So in the step 4 we'll write down like that. In the step 4, we will solve remove degeneracy. Remove degeneracy. Remove degeneracy, and we have to intersect, and we have to add it with intersect point and deduct from non-crossed line. So at first we have to create the format counter and salesman. Counter and salesman format we have to draw at first. So that is counter and salesman. A, B, C and D. A, B, C and D, and W, X, Y, Z. So at first we will look at 2. So in the second column and the second row, the 2 is the element, the minimum element. So we have to deduct 2 from other non-line crossed elements. So we have to deduct it at first 2 from. So if we deduct 2, so then if 2 deduct from 2, then that will be answer 0. So in the second column on the second row, that the answering the amount is 0. Okay, and in the very next column we can see there is 27. So we have to deduct 2 from 27, so the amount will be 25. The amount will be 25. 2 deducted from 27, so the amount will be 25. And in the next row, in the next column, that is 36, so we have to deduct 2 from 36, so the amount will be, so we have to deduct 2 from 36. Okay, so the amount will be 36 minus 2, 36 minus 2, that will be 34. Okay, that will be 34. Okay, again we will say our next point. So here the in the below row we can see here it's written that is 7, so we have to deduct 2 from 7, so the amount will be 7 minus 2, it will be 7 minus 2, it will be 5. It will be 5. And then we have to deduct 2 from 33, so the amount will be 33 minus 2, the amount will be 31. 33 minus 2, the amount will be 31. And in the next line, that will be 2, that will be 17, from which 2 will be deducted, so 17 minus 2, that will be 15. 17 minus 2, that will be 15. That will be 15. Okay, that will be 15. That will be 15. And in the intersect point we will add the 2 with the intersect element, so it will be it is written here 2 and plus 2, so the amount will be 4. The amount will be 4. and there is another intersect point in the below, that is 0, and we have to add 0 with 2, that will be 0 plus 2, that will be 2. Okay, go for it. So that will be 0 plus 2, that will be 2, and the other element remain constant on which the line has drawn, that is 28